It ends up everywhere. And then folks start analyzing and overanalyzing and sometimes improperly analyzing. So, there's a classical statistical mistake made in this article, and you'll find it as we go. So what do you think? I want to analyze what? What do I want to analyze? Why do I care about this? Why should we care about this? Besides back to the paper, often comes up in debates. I can see this kind of thing happening in a gubernatorial debate, where under your watch, people are dying left and right because you said it's okay not to wear helmets anymore. Right? You said it's okay, and now people are dying. Look at all these people that died. 402. 402 from 99 to 2009. Excuse me, 402 in 2009. Excuse me, 402 in 2009. Awful. Awful. You can't kill yourself in the mirror. How can you go to bed at night and kill yourself in the mirror? Killing 402 people because you told them they didn't have to wear helmets. Now, don't question the 402. Because there's all kinds of reasons why you should. From the fact that, were some of them wearing helmets when they died? The ones that were wearing helmets when they died, were they fitted properly?
Or were they drunk and not wearing a helmet?
Were they drunk and not wearing a helmet? Right? There's all kinds of reasons why you should suspect, just like why we should suspect that 172 with the appetite loss. There's all kinds of reasons why you should suspect the 402. All kinds of reasons. Yesterday, just to bring up a point of this yesterday, I was sitting in a writing class. We have these peer teams. And an essay the kids had to read was on caffeine and energy drinks. Caffeine and energy drinks. And the implication was that energy drink manufacturers should put labels on their cans that show how much caffeine is in them. I didn't know they didn't. I didn't know they didn't. I thought it was already on there, but apparently since it's not a food product, it's not labeled as a food product, they don't have to. So, the article in the paper, and this is such an interesting thing, a student had written the paper, it was a student at a different school they were reading, said some energy drinks contain as much as 5,000 milligrams of caffeine per 20-ounce serving. And that made my butt just like drop. Like 5,000 milligrams of caffeine, that's like 10 cups of coffee or something. Or 5 cups of coffee. It's some ridiculous amount of caffeine. And that's just the caffeine, not the taurine, not everything else that kind of acts like a caffeine element. And I was just like, oh my God, how would you drink that? The name of that one was actually called cocaine. Cocaine energy drink. It's since been pulled off the shelves. It's since been pulled from the shelves because of obvious reasons. But I thought to myself, I'm like, oh my God. I remember drinking a Red Bull once in '98 and vowing to never do it again. I mean, I'd never do it again. But I said to myself, holy crap, 5,000 milligrams. And then I went and I looked. And I got a laundry list of all the energy drinks on the market right now and the caffeine elements. 5,000 was one of the rare exceptional birds that lived out on the right side of the bell curve. The vast majority of the ones I found were like a cup of coffee or a can of Coke. So what did the author do? Of course, exacerbate the point by using an outlier, much like using Jared for a Subway ad. Exactly the same thing, right? Exactly the same thing. So the point is be careful with that 402, make sure they're not outliers in there. Or just attack it purely statistically, which we're about to do. Accept it. Accept the fact that there's 402 died. Let's take a look at what that means. Okay, so, what's the point of this article in the paper? Point of the article in the paper, friends? Good. More people or, well, are we going to measure more people dying? Because the problem is, I don't think we can kind of get it indirectly, but not so much more. I'm picking on your wording, Daniel, just a tiny bit. The death rate, so the percentage of death, and that's okay. Only because we had the death rate in 1999 at 0.000745. And the problem was, I don't have the number of bikes then, but I have the death rate then. Does that make sense? So since I have the death rate, in lieu of the number of bikes, I really can't tell how many died back then. So it's kind of hard to go apples in that way. But I can go apples if I look at rates. So what am I interested in right now then in 2009? If it's higher. So I want to see what's the Florida motorcycle death rate in 2009. What is it in 2009? Is it higher than it was in 1999? Or is it arguably what? The same or even less? And Cassie, when you said the same, if you put an equal sign here, I'd be totally happy. Because that's convention. That's convention. No change. Basically, I like to put the opposite of what's in the research just because as a mathematician, I like complementary kind of ideas. But you go ahead and put equal signs, so that's what you're going to see most of the time in the literature these days. Cool? We got ourselves some sample data? We do. We got about 590,000 bikes, or registered number of motorbikes on the road. I'm sure that number's not exact, it's the best number I could get. How about the number of fatalities? This is in 09. This is in 09. Number of fatalities, I quoted it earlier, right? That was the 402. So the p hat is going to be 402 out of 590,000. 402 out of 590,000. Good so far? You guys buying this argument so far? Well, it's not really an argument yet. It's just setting up for the argument, setting up for the conclusion. So here's going to be 0, and that 0 is going to be the Florida motorcycle death rate in '99, which we're trying to see if we're anywhere near anymore. So that equates to the Florida motorcycle death rate in '99. Our job, you guys are already on it. You're already crunching your numbers, aren't you? You're already crunching your numbers. Yes. Let's see if we end up over here in the 5% area, which would imply a significant spike, in death rate in Florida in 2009. Yes, let's.
So is this a one tail?
Because we're going to see if it's greater than. I'm going to test your hypothesis. Yes, Danielle. And Danielle asked if it's a one tail. This will always tell you how many tails right here, my friend. If it's a greater than or less than sign, it's always going to be a 1. And I liked your claim. Your claim was great. Let's see if it's bigger. Makes it one tail. Not necessarily different, just bigger. So I'm giving that burden of proof a break a little bit, Will. All right, there's last tests. On prop Z, P naught 0.000745, yes. Scientific notation, no big deal. Our X is 402. Our N is 590,000. Got enough zeros there? I do. And we're trying to see if it is greater than, if it's above 0.0745. Okay, here we go. Let's draw it. Test statistic. Test statistic. Give it to me. Give it to me. Test that. Please give it to me.
1.79.
There we go. Oh, thank you. It's very nice.
1.79. That looks significant, doesn't it? Negative 1.79 is way down south of that negative 1.6. But what were we testing? That the rate increased. That the rate increased.
That'd be decreasing, wouldn't
So, come back to that. Give me 2 minutes, Eric, please. 2 minutes. Hear Eric's just his counterclaim to the study? He said, wait a minute, this looks like it's decreasing. Hold that thought. Hold that thought. We're agreeing. Drew's agreeing. P-value, friends. 96%, which is what? Way bigger than 5%. Who do we believe? Which hypothesis do we believe when we get a big p-value? Null or research?
Null.
The null with a big p-value. A p-value is a conditional probability that shows how much your null hypothesis agrees with the data you got back. Your null hypothesis says the Florida motorcycle bike death rate either stayed the same or got less. A large p-value says your data shows it either stayed the same or got less. It doesn't show that it increased. So in other words, remember we're testing. We're still testing Danielle's claim. We haven't gotten Eric's yet. Danielle's claim was, it looks like the Florida motorcycle death rate increased. Can we agree with that? Hell no. It doesn't appear that it increased. As a matter of fact, not only does it not appear that it increased, it appears that it decreased. Watch this trickery. If you got that data and said, holy crap, it looks like it went down, would you have to run the entire test again to see that? No. You would want to run this as a less than, wouldn't you? You want to run that as a less than. But you don't have to based on what you see on the board, because what would the p-value be for a less than? What would the p-value be if you tested that as a less than? You can see it. It's whatever's left over, isn't it? About 4%, which is actually less than 5, which means not only have we disproven the claim it's gone up, we've supported the claim that it's gone down.
So making like how it's not illegal makes people.
Careful! Oh, careful over here, right? Careful. You hear what Chris said? He said, so making bike helmets optional kills people less. What mistake could we make there? Outside of type 1, type 2 errors, what mistake could we make there? Bunch of C words. Correlation does not imply causation. Just because it happens at the same time doesn't mean one caused the other. It could be lots of things. Give me one reason why the Florida motorcycle death rate could have gone down even in lieu of helmets.
Less people on motorcycles.
There are actually more people on motorcycles, but the same number of fatalities would drive the rate down. If 400 people died in 1999 and 400 people died in 2009, and there are twice as many bikes on the road in 2009, the death rate's going to be cut in half. Does that make sense?
Yes.
Is that fair? Okay, good. There's one reason. What else can happen over a decade? Better what? Oh, go ahead, Danielle.
Less people riding or.
Oh, it could be that fewer people are riding, but the statistics actually say otherwise. There are more registered bikes. Oh, wait. There are more registered bikes, but maybe fewer of them are riding as much. That's what you're saying. And that actually goes with what Rosie's saying, too. It might be that there are more bikes registered, but not as many people actually using them or not using them as much. That's good, that's good. I was thinking better education. Kayla, is that what you're going to say? I'm sorry, I just took your answer from you. Yeah, better education. Exactly, better endorsements on your license for that kind of stuff. And there's all kinds of reasons that would. Maybe it's this too, but we can't say it's this that causes it, Chris. Is that fair? Is that believable? Okay. So sometimes a test that doesn't show you anything shows you a lot. It might show you something completely opposite of what you're. And this one didn't last very long in the papers until people just descended on upon it with fury, the fury of the closet statistician. Yeah, the armchair statistician. I got one more for us. How many of you from 243 remember this? Remember this? Let's